two progressive sound waves Y and Z meet at a fixed point, the variation with time of the displacement x of each wave at point P is shown. Achha, this is a problem with this chapter. That's why we finished both chapters. Even school did the same. Actually, these two chapters are always coexisting. They come together. And this is why you will find the concepts mixed together. Two progressive sound wave Y and Z meet. So when they say meet, it means that it's some type of superposition. The variation with time of the displacement of each wave at point P is shown. Use figure 4.1 to state one quantity of waves Y and Z. Read the question, please.
Sure. So direction remains the same?
Direction is a possible solution, but as I already have hinted, Saad, that this is a case of superposition. Looks to be a case of superposition also. So we have to see the time period, maybe the frequency, maybe the amplitude. So keep the superposition chapter also and in your mind. So read it once and then we are. Okay, so the two waves are meeting and at a fixed point P. P is a point where the waves are meeting, and you can see carefully that one wave has a shorter amplitude Z and one wave has a bigger amplitude.
Yeah, amplitude remains different.
Amplitude is different, definitely, right? Good judgment. Now we have to see, we need to see what is the same. Can we check for time period or frequency?
Frequency, sir.
Frequency looks to be the same. Did you check it? Time period?
Yes, sir, it is.
So, we are doing June 2023 4. So as my discussion with Saad, and I hope Ariba, if you also take part, because past papers are well done. If everyone contributes, right or wrong is not a problem because it's a test mode, not a test. Now, we have an observation that one wave has a bigger amplitude than the other. Now, as I advised last time also, that you can keep a digital device with you in the class. If you find a paper which you do not find in your book or question, you can just open it on your device and solve with me. This will be a record for you because with the passage of time, you have to do so many questions because it's a competition of at least 2010 to 2023. This is where all A expecting students go. This is a very big range, 13 years or 12 years. State and explain whether waves Y and Z are coherent. It's a very tricky question because now we have to see the x-axis is time. Time period is the same. Frequency is the same. And he is asking a very technical question, coherence. Now, what is coherence? You all should answer now. One by one. Saad, can you please answer what is coherence?
When two or more waves have a constant phase difference.
When two or more waves have a constant phase difference, Ariba, you please also tell that. Is it necessary the waves should have the same wavelength or time period should be the same? Otherwise, coherence cannot be found. For coherence, it is necessary that they should have a constant phase difference. They should have a constant wavelength. Otherwise, they can't be said to be coherent. Now he says, state and explain whether waves Y and Z are coherent. So I check it by taking a sample here. And I see the difference. and I take another sample and I make a line here. Now I put question mark here. I am not very precise because this is actually a digital PDF. So if you keep if you look it very closely, is the phase difference constant? The gap.
Yes, sir, it's constant.
Okay, now I need Ariba, is it constant? The difference Saad is saying is same. Noor, please you also contribute. We are doing June 2020, 23, 4. But quick response is needed. I have marked it. Phase difference means gap. Is the gap same or gap is changing?
It's the same.
Gap is constant. Okay, Ariba, but you can also Ariba, answer on the chat if you want. If you are comfortable on mic, it's also fine. Now, we have a consensus that phase difference is constant. We have shown it. So I write my answer. State the waves are coherent. I will say yes. Why they are constant? As
Difference between 2 points to as they have constant phase difference.
I will focus on that. Phase difference is constant. You can also, Ariba, try to, if you have any past paper book, you can open it. And Noor, you also can open any past paper book you have. Just match the year, and it would be ideal that you people write with me and make a record. School, tuition together. You can do a lot of questions. Otherwise, then every time you do a question and no record, then you would be doing the same question after a month, after a 2 weeks, 3 weeks. Determine the phase difference between the waves. Now, this is always a tricky part that remember that one time period corresponds to a phase difference of 2 pi radian. One cycle corresponds to a phase difference of 2 pi radian.
Yeah.
Now, I have to find the phase difference between the two waves. He is giving me one mark, and answer unit is degree. So now solve it, and I'm showing that again the two waves. Give an idea, and I need an explanation also, because if you say any angle, I repeat my concept of this chapter that this is one wave, this is one wave, this is 180, this is 360, and this is 0 degree. Our chapter concept was there that one cycle is always 360 degree. So I can measure tip to tip, and you people can tell me if 1, 2, 3. If I'm taking wave Y. For wave Y, the bigger wave has 360 degree in 1, 2, 3, 4, 5. You can count the divisions. So this is, remember I'm taking wave Y. So wave Y has 360 degree here. This is 0 degree. And I have made a question mark. I have made a question mark. So now you people can apply. I remove this question mark. I remove this, so avoid confusion. There are two positions. Okay, now tip to tip. So I can find the phase difference. So can you people tell me how many divisions are there in my marked question mark segment?
Sir, 10.
10 division. Okay. Acha, can you tell me, all other people please contribute? Saad is saying this. Saad, how many divisions there from 0 till 360? This total division, if I mark, are there
30.
30 division?
Yeah.
And you are saying 30, how many divisions you are giving me in the question mark?
10. There's 10 divisions, sir.
10 division. So I mark here 10 division. So now apply ratio. 30 division 360 degree, then 10 division would be
120 degrees, sir.
This is the method, and now you people understand that why I was saying that you should have paper in any form. Just make a backup of any digital device and open it on it like a iPad, anything, and just save on it, because these workings are necessary, and you can't actually remember it when you leave the class. And I have shown this working. Now I will say that I will tell examiner that look, 30 division is 360 degree. So 10 division is x. X is equal to 360 into 10. On 30. Now this working is from here. How we find the phase difference between two waves? Take two common positions like two crest, two trough, and subtract them in terms of division. Remember, one cycle is 360 degree. Now we move to our next part. The two waves superpose at T. Use figure 4.1 to determine the resultant displacement at time is equal to 0.75 millisecond. Now read this question, read this part. 0.75 millisecond. 0.75 millisecond.
So isn't it just 0.7? 0.
0.75. It means it is,
Oh,
if I mark here, it is 1. If I mark the center, it will be 0.5. So I need a center again. There. This is 0.75. So at this point, we need to read the amplitude of the two waves and subtract them. I have a number 0.75, the two waves superposed. Determine the resultant displacement at time t. So now the graph is in front of you. You people have to help me. 2 micrometer. 2 micrometer. What's that? 2 micrometer? What?
so 2 micrometers is the resultant displacement.
Actually, no.
Sorry,
You need
no, it's not. It's 3 micrometers, sir. Sorry.
first read from the top and then read
Yeah.
from the bottom.
Yeah, it's 3 micrometers.
if I read from the top, 3 micrometer, okay. If I read from the top and I read from here, there. If I read from here, it's coming 4. And if I read from the bottom, it's coming 1. So it should be 4. It should be 4 minus 1. Ariba, what entries you are subtracting? One number is coming 4 and the second number is coming 1. So if we mark from here like this, so the answer is 3 coming from 4 minus 1. If I read from here, it is 4. And if I read from here, it's coming 1. The intensity of wave y at point P is I. Determine in terms of I the intensity of wave z. Now the formula I1 upon I2 is equal to A1 upon A2 whole square. We had a formula of this version.
Sir,
Let's write down the formula first. I1 upon I2 is equal to A1 upon A2
squared.
whole. So you people try this part. I am just coming. I have to say namaz and I'm just coming. And you people should do this question. You have the year number and you people just have to finish this and I'm just coming back. Then we can compare the working and compare the answer.
I'm done, sir.
There is another part F now. Please. How we do part number E?
So we convert, yeah,
One amplitude is 4. One wave
Yeah.
has an amplitude 4 and the other wave, if we read from here, one wave has an amplitude 4, other has an amplitude 2. The intensity of wave y. So if I take y as my numerator, y is that bigger wave or smaller wave? Y is that bigger wave? So let me put it like this. I do not know I1 and I put here the bigger wave is down. Smaller wave is in the top and bigger wave is in the denominator. So when I solve it, it will be 1 upon 2 whole square. Then I1 is equal to 1 upon 4 I. I'm taking y as 2 and x as 1. Z, sorry. So one wave is y and one is z. So this is the working. If you people have any query, you can always ask me. This is our type of paper questions or trial work.
Done, sir.
Right now, next part, the speed of z is 330. Determine the wavelength of wave z. The formula I will write, v is equal to f lambda. Lambda will be equal to v upon f. I have the z, I have the speed of z, 330, but what about the frequency? Can I get frequency from here for wave z, or should I use directly the time period? I think it would be better if I use the time period formula because I can read time period directly. So
Sir.
V is equal to f lambda. So I can say v is equal to lambda by t. Lambda is equal to b into t. V is equal to 330. Now, what is the time period of v wave z? If you people can see this graph, look, this is the graph. I have wave z. What is the time period of z? One cycle. Time of one cycle. I can take a position here, and I can take a position here, and this will give me the time period. Now, it's time to read for me. You can count the boxes, or you can count the bigger boxes or smaller boxes, but everyone should contribute. Yes, Ariba, you can write on the chat. The voice is not clear. You can write on the chat, please.
So the time period is 3 milliseconds.
Okay, 3 milliseconds. So we take this value, 3 milliseconds. So I will take it 3 into 10 to the power minus 3. And now solve it to find wavelength.
$330 divided by that is
We can directly solve it.
0.99, sir.
0.99.
Yes.
Right. So we are done with that question and we are returning to our work. We have done one question and I think we should put some more revision. And